about to leave. Already packing, come with me. I'm not really asking. We'll get away to a place where we don't know.
Hi, I'm Robbert Noordzij. Thank you for joining. Today, I would like to take you on a journey on building a resilient passenger information system for the Dutch railroad network. Imagine a day before Corona and probably also thereafter that 1 million people a day commute from home to work and back in the evening by train. And also in the weekends, enjoy their occasional visits to the zoo, museum, or theme park, and also using the train. For NS, one of the most important activities next to being an operator of trains is running the passenger information system. Passenger information is not only the information about which train is on which track, but also the planned schedules for maintenance and also the disruptions. Especially during disruptions, the unplanned ones, it's very important that the information about train operation is up to date and accurate, so that the travelers have the options to take, for example, a different modality, a different route, different train, or even postpone their journey when there are no trains. Today, I would like to take you on the journey that we took to rebuild this system, and actually went from a plan that would took us 8 years that would only take us a few months. I'm Robbert Noordzij, a senior software engineer for NS for now 2 years. Since 1.5 months, I'm the proud father of a daughter, so I have a few sleepless nights behind me and probably also ahead. This is currently my team. We are working with 3 developers, informational analyst, and a product owner on the core of the passenger information system. And next to us are teams that are actually providing the sources and using the products that we create to actually display that on signs or distribute it further. Let me give you some context on the passenger information system as we currently know it. In 2001, this was still a normal sign on a station. This signage has been serving us for years. But you could imagine that it's really hard to change. Every year, a few months was planned to actually change the flaps of this sign with the new trains, with new destination, different station names, and also different routes. And in case of big disruptions, it was not always possible to actually show the right train because it would take a different route on the right track, on the right sign. So back then, it was already decided that we needed a system that would be flexible and could change rapidly. Like I said, passenger information is not only for us. NS is running that system, not only for the NS, but also the other operators on the network. And it's visible through a lot of different channels. One of the major channels is all the operators have their own website and apps. But also there is one major app across different modalities that is 9292 that also consumes our information. And through the open data channels that are provided, a lot of hobbyists are creating wonderful solutions for specific needs or general needs. And they're all out there to find, which is really nice. And of course, the most visible one for a normal train commuter is the sign on the platform itself or the station itself. The current system was changed in 2006, and because ProRail is actually responsible for dividing the capacity on the railroad network across all the different operators, also the cargo trains, passenger trains of all the different operators, special occasions like steam trains, and doing that all safely, the passenger information system back then was an afterthought for ProRail. So back in those years, it was actually handed over to NS, and now NS is responsible for running this system for all the operators. But still, it's almost 15 years old. And with the growing numbers of passengers that we expect, and also the growing number of trains we expect in the future, we would like to be able to add more features to the system to provide better passenger information system. However, in the past years, we have seen a few major incidents on updating the system, changing it, releasing it. The release of the system sometimes takes more than 4 hours, and also a rollback can already start taking a few hours. So it's really hard to maintain. It's really hard to change in the future. To give you some context on how the system works, I would like to show you that it consists of different streams. It's not just one information stream from ProRail, this train is going from A to B. It actually consists of a lot of layered information messages. So for example, at first we receive a scheduled plan, probably some 10 days in advance. And that's already a lot quicker than in 2001, where it already needed to be a year in advance to actually change these flaps. And this is something we would love to reduce to only a few days so that we can improve and iterate faster on the operations. Next to that, we have the train running information that is actually, well, this train was expected to be here at this time. It's now on this time. It is now at this time here. And from that, we can derive the delay or even that it is running ahead of schedule. Next to that, we get the signaling information. So the train is actually on this spot on the track. And then we have the object info message, which is a high overview of the locations the train is actually passing. This does not consist of tracks. This is only saying, well, this train is now going from Rotterdam to Amsterdam. And when it changes it, it only says, well, it is now from Rotterdam to Schiphol. And from that, we can derive that it's not running past Schiphol anymore. But this is still without the tracks. Tracks are a different system, and that's because the actual operator of ProRail responsible for that station can change that well, more or less last minute, and it's not across the whole network. It's only specific for that region. So it's actually 13 different systems that deliver track information for that specific region. And then everything in the system is using codes and numbers, which is not really helpful for passengers that are in the train or next to the train. So we have to translate these codes to the full name, and that's something we call STAM, which is the general information. Still, the system is pretty big and not everything is automated. So there's still a person that is actually able to change information and update information or replace information, for example, when one of the streams is broken. All this together actually combines into a dynamic train departure message, een dynamische vertrekstaat, which is published through all the channels and results in something on the signage. The current system consists of a few modules that are working really closely together. And we actually consider it a monolith by that. On the left, you see the sources from ProRail and the source, other sources that we have. They all stream into the monolith, and it results into a AVS. Like I said, we would like to be able to have a more resilient system, containerized on OpenShift with microservices, so that we can actually that we are able to change modules quickly. That we can release them in their own pace, that we can use different technologies for different problems. And the main architecture would be event-driven and using REST to actually receive the state from these different microservices. This is already a few years back, and so the plan was drawn up to extract all these modules from the monolith into their own microservices and step by step, bit by bit, it would change, and we would have a dynamic train departure message stream on the other side. This would work, and it would change for everything. However, the plan would take almost 8 years. Was planned, was estimated, and it would affect all the stations in the Netherlands at once. And by that, the impact would be really big. And the problem with it is that we still needed to deploy and still needed to change this big monolith, which was risky, which is hard, which takes a long time. And that's why it would take 8 years. So me and my team actually drawn up a different plan. We, with the organization, we came up with this idea to actually duplicate all the incoming messages from this system and start with the most basic source, which is the scheduled information. Build a microservice that receives this scheduled information and returns it as a state for this new module that can create the dynamic train information message. And then after that, we could add the other sources. And when this all was done, or even in the meanwhile, other teams could already connect to ProRail directly, so that it would result in a, and then we could scale down the monolith in the end. The nice thing is, since we would start with scheduled information, we could, for example, start with a single track station. And since a single track station cannot have any change in track, we could already run these stations in production with only the planned information we have. But the big question was, how can we keep it resilient and feature-proof for the upcoming years? We came up with, since the current system is pretty well documented, we could run all the unit testing for our new system based off the business rules we already have. We also would be able to add new functionality directly, create unit tests for that, and we would have integration tests to test and check the underneath communication between the different modules. One other nice thing of our new approach was that we could use contract testing for the sources and also for our consumers. So, and these contracts are, for example, the XSD for XML and the JSON schema for the JSON interfaces. Because now in this new plan, the interfaces on the source and the interfaces on the end would stay pretty rigid. And eventually we could actually change them out for a more European standard, which would be nice for future use and also reduces the need of our own custom messages. During the build and during the first phases, we found out that the deployment of different modules could still interrupt the mainstream of information. How we solved that was actually doing a retry, and that also we also do the retries for the database transactions. So when it's recoverable, we retry the operation, we retry the state, and when it doesn't result in a change, we don't do anything with it. For example, we receive a message that the train is moved from track 1 to track 2. We try to update it, and for whatever reason, maybe a concurrent update, it fails. And then we could retry that operation to move the track for that train. And when it doesn't work, most often it would result in a successful message, or when it completely fails because the train was canceled already, then the message can be ignored. For most of the situations that we see in our daily operations, this is enough, but it can still happen that a source is completely lacking or failing during operation. In those cases, we try to be as accurate as possible. So for example, when we miss the delay information about trains, we can still use the scheduled information or the different positions of the train on tracks to recalculate delays. And also when the track information, the real-time track information is not available anymore, we can still degrade to the planned schedule. The current system is not doing that. When it receives something that is weird, or it doesn't receive anything anymore that is not according to their business rules, it just happens to stop. It doesn't calculate any delays anymore. It is not using any other source to recalculate that delay. And also a nice thing that we have in this system is that we can start over again. It's not per se a retry or a fallback, but in case that the core system fails, we are able to rebuild the state, our state, from all these source states in a matter of minutes. This really improves the resilience of the system and the reliability of the system by being able to replace it directly. In case of a failure, we can say, well, stop the system now, delete everything, and start over again from scratch. And within a few minutes, we are back on the track. A big change we do opposite of the current system is that we do many small increments. We change the system very often, and we also do many releases into production and acceptance even more. Compared to the previous system. The endurance testing we do for the old system takes 2 weeks. We don't do that anymore. We have different solutions for that. So we are able to have a higher pace and make changes very rapidly. And like I said, we now start with single track stations, and we want to go up from there. And we use feature flags to enable features for these stations, but also to enable stations themselves, compared to having a full release. These feature flags are really easy for us to toggle and give us the opportunity to see what it's doing and go back when it fits. To not have to do that on production, we duplicated our production streams to our acceptance environment, since it's not any person, since there is no personal information in that at all. It's only about trains. There are no names, there are no email addresses in there. We are able to do that, and it gives us a lot of insight in these feature toggles, and we can do that on the acceptance environment, and we can smoke test new features without having to see that in production first. Something that we have from that is that on acceptance we do something different. The current system is actually the current system is filtering all the trains that it doesn't know because it cannot find an operator or it doesn't know the station name. It's filtering them up front and thereby losing information basically. We said, well, we wanted to do differently. We want to have all the information, like all the trains, even cargo trains are in the system, but we decide on the end, the trains that we are sending out, we are publishing, and the trains that we are not sending out, we are not publishing. The same thing for stations. Like I said, on acceptance, we do something different. We have all the stations already available. We can see all the stations. We can see the signs of all the stations. We can monitor them. And we can already know, even though we are in production with only a few small stations, we can already see what the system is going to do on Utrecht Central, on Amsterdam Central. Also, what we do is we take the test data from production or from our acceptance environment and use them while debugging. And also, when we see an issue, we can take the train information of that system and put that into our test. And with that, we prevent regression from happening. So we started in January building this new system, and we had our first actual station running in production in July of this year on Soestdijk. And we were also able to add a new functionality to that. For example, It might seem really small, but in the old system, it was really hard to accomplish. The first train on this sign has now 4 via stations instead of 2, which is a major improvement for our customer. It would be able to see more information about the train in one glance instead of having to look everywhere. And especially for different operators on different routes, this is a significant change. And with this, we proved to the organization that we were able to have a higher pace, to build a resilient system that we were able to maintain in production and even add new features while we are building it. So for example, this is the list of all the stations we are now doing. Since a few weeks, we have the actual track information also available. So we can now have single track stations and double track stations. And we are now on 50 stations that are running smoothly with this new system. But like I said, on acceptance and also in production, the data is already high. And what I want to add to that is because the data is high, that in the case we see some performance degradation in production, we are able to add a new filter at front. So for example, lose all the cargo trains so we have less train manipulations in the system. So we can still add new features that might, we haven't seen it yet, but that might reduce the performance or might hit the performance. And by just tweaking the data stream at front, we can still have that feature live without retracting that feature, which is more valuable, and then we can change it later while there is time. Since the system is in production, and since we still want to have some insights in the system, instead of during the endurance test, we are more focused on the metrics. A few of these metrics are like the throughput, the number of messages coming in and the number of messages going out on the other side. These messages should have a pretty stable pattern over the day. And of course, it changes during disruptions. More changes to trains result in more messages. But it is a pretty decent metric for us to see if something is going wrong in production or either acceptance. Something else is a custom metric that we have on the queues. We actually measured the delay between the systems. And this is very important to us. Since the passenger information is more or less real time on stations, we want to have this delay of messages. So this is not the delay of trains, pretty low. This delay is for us a key metric. We monitor it over day. We have alerts on that. And we can also, and when this is going up, because the amount of messages is higher, we can then start filtering out trains that are not visible. Another metric is, for example, the database, the processing times, the computation times, the HTTP endpoint times. We watch them closely, especially during a release. So new releases might affect the performance of endpoints. If we see a change in that, we can decide whether to proceed to production because we have the production feed on acceptance. Or make changes along the way. This gives us a real high pace in feedback of the system because we can already see on acceptance what it's going to do on production. Something we already measure, and that's not only for us, but it's also for the government and as a proof to the other operators that we are building a correct system, is measuring the accuracy of predictions of, for example, the delays and the estimated departure times. The current system is doing that, and also for the new system, we are doing that based on the same messages. So the metric is exactly the same, the way of measuring is exactly the same. There's only an extra filter on there to split it on the stations we do and the station the old system is doing. And we can actually compare that if we are improving the system or making it worse. And currently, we are still more accurate with our predictions than the current system. Like I said, we are doing a lot of retries in the system, while most of the things are fixed with one extra retry. We monitor them closely, the number of retries, we monitor them closely so that we can see if they are going up. More retries would eventually mean that something is not working as well as it should. It could be that there is more concurrent, that there are more concurrent modifications on a specific train, or it could be that the processing time has gone up where things become slower, so more, and that results in more concurrency. And also, of course, the exceptions are monitored. Based on that, we have alerts, and this gives us the proof and the confidence that the system is stable. In conclusion, I hope that you have learned a lot of the current system and how we are building this new system, including new functionalities for the upcoming years. We had our first station live within a few months. We are currently on 50 stations, single tracked and double track, and we have our goal set that we have 60% of the stations before end of the year. Next year is going to be crucial because ProRail has to deliver new source information to actually disclose the last few stations that we then still have to do. And I'm really proud of this, but we have had 0 incidents, major incidents on these 50 stations. Of course, on acceptance, we have seen problems. We fixed them before it went to production. And also the things like due to concurrency issues, we have seen some trains failing, but then also we can fix that with the production data as new test to still improve the system day by day, bit by bit. Thank you very much for joining. Please rate my talk in the official JFall app, and I will be here afterwards for questions.
Thank you so much, Robert, for that really informative presentation. We're going to do some Q&A now, and there's a couple of questions. First of all, I'm going to head over to the questions section. I've seen a discussion in the chat, and I'll come back to that in a bit. You spoke about implementing feature flags, but how did you implement those?
Yes, cool, thank you. What we did was we have a service from Spring Boot, that is the cloud configuration service. And we use the YAML properties to switch flags in there. And after a restart, the new configuration is loaded. Also, we sometimes tweak the environment variables to actually override certain settings during runtime. But most of the feature flags are actually regular Spring Boot properties that we can manipulate.
Okay. Cool. And second question about someone that actually knows some of the internal systems of the Dutch railways. It seems when you talk about the monolith, are you referring to Harm and Chris combined, or is more of the original system replaced already?
No, I'm indeed talking about Harm and Chris. They were built in the years 2000 by other companies, and they are still running strong, but are pretty hard to change, and we have some big issues. We had some big issues with it in production. Mm-hmm. Okay. So yes, it's correct.
Okay, and there's been a little discussion about track safety and how the track might be divided into blocks for a train. Yeah. Can you elaborate some about the safety features that are in our national railway system?
Yes. At first, I want to be pretty strong about that especially because ProRail is the main party in the railroad safety. We are just doing the passenger information side of it. So the blocks, we know about them in the passenger information system, because each track is divided in blocks. A block can only be occupied by one single train. And the signaling actually prevents a new train from entering the next block before the first one has left it. Mm-hmm. But that is all part of the ProRail system. We don't do any manipulations on that. We only receive the information kind of on a read-only basis. So passenger information is in no way responsible for any railroad safety.
Okay.
So I wanted to make that clear, that it is something different. We only consume the information from Proto, and Proto is still the main operator of all the switches and signals.
Okay, that's good to hear. Thank you. Next question: how did you convince the business that you should provide inaccurate information when some of your input fails? Because that was like a no-go a couple of years ago.
Yeah, what we actually considered that when there is no information and when it's actually wrong, that we would try to prevent it from serving. But if it's inaccurate, because we can actually, for example, the delay information, if it is off by a few minutes, then that's still better than no delay information. And if we still know that the train is actually moving or switching track, that is still better than completely stopping all the information. That's currently happening. If one of the sources fails, then the complete passenger information system stops publishing new information. And we were able to convince the business part of our organization by showing them the situations that could happen and actually implementing fallbacks. So, for example, the current system uses only one source, and we try to derive the same information from a different source as well. It might be a little bit less accurate, but it's still more accurate than displaying nothing at all. And that makes the big case in saying, well, okay, if it's still better than no, then nothing, then let's do it. And there is always an option to manually intervene with the information. So there is always someone who can actually enrich the information and make sure that it is still correct.
Okay. Next one, do you expect any problems when going live with big stations like Amsterdam Central Station or Utrecht, for instance?
Now, like I said, about the block information, that is one of the sources that we are still missing. What we see happening is that trains might go into a different platform, and we can derive that from the low-level block information of trains. Because we are still missing that source, we have a big risk currently that trains might end up on the wrong sign above the wrong platform. When we are able to receive that information, we don't see any problems why we shouldn't go live on these big stations. Currently, we are already running them on the acceptance environment, which is more or less equal to the production environment, only different. Nobody is actually seeing that. And we are running them already for a few months. So yeah, we are pretty convinced that it should have no problems at all.
Famous last words. We'll find out eventually.
But the strong thing is what we do now is that we are able to change things quickly. And because of the feature flags, when we see with a new release of stations, when we see it go wrong, we can still switch back to the old system. So the impact for travel for passengers is less.
Okay. Cool. Great answer. Thank you. Next one. Do you do your own deployments, or is that outsourced?
That is actually something that has been changing within the organization. We are able to do our own deployments now. Everything is scripted as code. We need to still have an improvement from one of our operational partners. But when that is done, like 5 minutes after I deliver the deployment, then it will go into production without any manual intervention.
Cool. Okay. Then the last question, and it's already partly answered, but can you tell us a little bit more about the technology stack that you guys are using?
Yeah. What we are currently using is Kubernetes, partly OpenShift, for running the containerized microservices. Within the microservices, we run Java with Spring Boot. And behind that, as a data store, we mostly use Postgres, but we are also looking into new technologies to solve different problems, and also already improving the system with, for example, GraphQL or having a document store instead of a relational database. So the stack is changing quite rapidly, but the solid base is still Java Spring Boot for us, at least. Other teams use different things with a relational database behind it on a Kubernetes cluster.
Okay, cool. Well, I see we've got a little bit more time, so I'm going to pick one of the next questions. It's, well, you work for the Dutch Railway, so this is a really good question. Did you go to work by train, and did you team?
Yes. On a daily basis, I went from Rotterdam to Utrecht by train. Even on my first day, I had the problems that everyone has with trains. But yeah, we went. Yes, most of the team went by train. Some of them work and live in Utrecht. So they were close by, but nowadays during Corona we work from home. We use Skype and Slack to do our sessions.
Like most of us, I suppose.
Yes.
And the last question before I'm really gonna end this session is: artificial intelligence a part of the passenger information system? If you know.
Well, I can tell a little bit about it. We are trying to, because like I said, the track information is always derived later by different systems by ProRail. So when we receive a new train, we don't have any track information. And what we are now trying to build is something that can actually predict more or less on the pattern that we have seen in the last few days or trains to select that train up front, to select the track up front. And that would mean that we can already deliver tracks hours in advance. And that will mean that people that are using wheelchairs can actually be at the right platform earlier than it is currently. So yes, we are trying to improve it, use that, but it's like a little part yet. But we have big plans for that.
That's good to hear. I'm looking forward to seeing that in action. Well, Robbert, thanks again for your lovely presentation and Q&A. For everyone else, we're going to have a 10-minute break, and I hope to see you all shortly. Thank you again.
Thank you.
About to